I recently got a trial account for Google Cloud Platform and I wanted to try out a few things to see what Google has to offer. And I also wanted to learn more about big data. So I figured the best way for me to learn is to get my hands dirty. So I wanted to do something that is of interest to me. So what we're going to go through today is we will be looking at how do you price options by using Google's Dataproc product or service. And we're going to be using doing Monte Carlo simulation to do our option pricing model. So what we're looking at is an empty project. I've called this option pricing, not a surprising name. Now the next thing I'm going to do is I'm going to create or enable my Dataproc cluster. So I'm going to click on that icon at the top left and scroll down to Big Data and click on Dataproc down below. And it tells me that I have to enable billing before I can continue. So I'm going to go ahead and do that. Choose my billing account, set up. That's already all done for me. Now I'm going to click on Create Cluster. It's going to tell me it cannot go ahead and do what I requested. And the reason for that is I have not enabled the API yet. So I need to go back here, click on API Manager, and I'm going to click Enable API and type in Dataproc. I'll explain in a minute what Dataproc is. I'm just going to click Enable. It's going to take a few seconds while it does that. So Google Cloud Dataproc, what exactly is it? It's basically Google's managed service for Apache Hadoop, Apache Spark, Pig, and Hive. So Google is making it very easy for anyone that wants to utilize those open source software, and you'll be able to utilize all the features and benefits without having to worry about the administration side of things and installing them, configuring them. Everything is done for you. So this is going to take a few more seconds, and when it's ready, we can go ahead and create a cluster. This is done, so it didn't take us very long. Now next thing is we will go ahead and create a cluster. So let's go back here. What we did just now was we enabled the API, and I'm going to go over here and create a cluster. So I'm closer to US East, so I will go ahead and select US East 1B as my zone. Now you notice there are two sections here. One is the master node and the other is the worker nodes. So the master node is responsible for managing the resources. It's also the Hadoop file system name node, which is responsible for keeping track of where the files are, etc. So you can see here we get an option to select what type of machine we want to use in terms of resources. By default, it's picking N1 standard 4, which is 4 vCPUs and 15 gigs of memory. I can go ahead and change this to something slightly smaller given our sample or our sample project here is not that intensive. So I'll pick N1 standard 2, which is 2 vCPUs and 7.5 gigs of memory instance. I will change this from 500 gigs as my primary disk space down to 10 gigs. And the worker nodes. So the worker nodes are the instances of the VMs that will be doing the actual calculations. So again, by default is N1 standard 4. So again, I'm going to pick N1 standard 2. Minimum is 2 nodes here. And I will again change this primary disk size down to 10 gigs. And one thing I want to point out is down here, yarn cores and yarn memory. So where this number 4 comes from is it takes the number of vCPUs from the machine type and multiply that by the number of nodes. So here you can see I have 2 vCPUs times 2 nodes, so that gives me 4 cores. Now similarly, you notice yarn memory is 12 gigs. Now I know we have picked N1 standard 2, which should give us 7.5 gigs of memory, but only 6 gigs of memory will be allocated for executing the job. So 6 times 2 is 12 gigs of memory, and that's where 12 gigs comes from. So I'm going to go ahead and click on create. This will take a few seconds to provision. So while we let that provision, I'm going to go ahead and show you what we're going to be pricing today in terms of an option pricing. So we are going to be pricing BlackBerry. Of course, everyone knows who BlackBerry is. Used to be one of the big juggernaut in the Canadian high-tech space. Unfortunately, it has not been faring very well. But we're going to be using this as an example for today. So there's some numbers from this page that we're going to be using. We're going to be looking at the $7 strike price call expiring on November 18th. And you can see here that the implied volatility is 36.72%. Now, just one note before I go on and start looking at the code and whatnot is that the focus of this video is not diving into how Monte Carlo simulation works or explaining what that is. The focus is really on how do you use Dataproc on Google Cloud Platform so you can do parallelized calculations and whatnot. So here we have this is the option that we're going to be trying to price. And so I'm going to jump over. Let's take a quick look and see where we are now. So you can see that the cluster is already running. So it took about a minute for it to provision, and everything is all configured. So that includes our, a VM is deployed, and we have all the necessary software that we need in order for us to parallelize this computation. I can click on this, and this will jump in, and it will tell me how much CPU it's using right now. You can see we just started this cluster, so it's not using a heck of a lot. I can go over to VM instances, and I can see I have 3 instances. Cluster 1-M is the master node, and then we have our worker node 0 and worker node 1. I can go ahead and click on SSH. And this, of course, will bring up an SSH terminal that we're all very familiar with. And while that runs, I'm going to jump over to our code just to highlight a few lines here. I'm not going to go into details, but just highlighting a couple lines. So right at the top here, we are importing some modules for our Python script that will be doing the Monte Carlo simulations. And then down here we have some variables and some values. Volatility here is what we saw earlier in terms of the implied volatility of our $7 strike price option. Here's the strike price. Risk-free rate, so where I'm pulling this number from is from the daily treasury yield curve. So here you can see in a month that the interest rate for 1 month treasury yield is 0.24%. So I'm using that as my risk-free rate, as you can see here. And the current price of the share is $7.37. Down here we're calculating a few other things. I'm going to skip over that. And the point that I really want to show here before we go into other lines is this function here. So what this function does is it takes in a seed and it randomizes this based on the seed that you provide. And we'll go into what exactly that seed is when we execute the script. It takes that seed to initialize a random number generator, and then it goes ahead and plugs it into this formula. And it returns the call payoff price. Okay, so let's jump back to our SSH terminal, and I'm going to run PySpark, which is the Python interpreter for Spark. It's going to take a few seconds, and we'll be seeing the terminal or the prompt very shortly. I'm going to come back here and copy this code. And come back here. So here we can see this prompt, so I can go ahead and paste this code in, hit enter, and that's it. So now we have the code in memory. Now let's look at the next line. So this is where the start of the magic is. Right, so here you can see we have sc.parallelize and then some number. So sc stands for spark context. The parallelize function it's pretty cool. So what it does is it assigns a distributed data set called RDD, or resilient distributed data sets, and it creates this data set so that we can operate on this data set in parallel. So if we take a closer look at what I'm passing in the current time plus this range from 1 to 10,000. So what this is going to do is basically we'll create 10,000 numbers, 10,000 different numbers, and we'll be passing that into as the seed to generate a randomized number. And this will be put into this RDD, or resilient distributed data set, and we'll be operating based on that. So I'm going to go ahead and copy this into this window. And now one thing about Spark is it does lazy evaluation. So it doesn't really actually do anything yet until we go ahead and get to the computation stage. Now the next line, again, this is pretty cool, pretty neat stuff. This is where we are passing in the data set element to this function called sim option price, which we have already looked at up here above. And this is the map phase. So what this does is it distributes this function to and along with the RDD, and have the worker nodes to calculate the call payoff. And it will be stored in another RDD called results. So I'm going to go ahead and copy this and paste this in. So now this is telling Spark to go and distribute the calculation to the worker nodes. Now we have 10,000 different numbers that comes back from running this in the results. So we need to aggregate all those numbers back so that we get one final output, one final result. And that's what this reduce function does. Right, so the reduce function takes another function. I'm going to take the add function as the aggregator, and we'll be storing that into the sum variable. Right, so I'm going to go ahead and copy this and paste this in. And you can see it's doing something there because, again, this Spark is using doing lazy evaluation. We will be using the sum variable, or we would need the value of what that is. So that's why I went ahead and calculated. Now the next line is where we calculate the actual price. So what we did was we added all the valuation that we got from this function, and by calling this reduce function here, and we are calculating the average value that we got back from the distributed function call that we just did, and we add the discount factor as well. So I'm going to paste that in. So now we have the price variable set. So finally we are going to be pasting this formatted price. So it looks like, based on our calculation or simulation, the call option should be worth 52 cents. So let's go back to our trusty page here, and it looks like the final price for today was at 55 cents. So it looks like this is overpriced by a little bit. So if you want to trade on this option, then maybe it's better we don't go ahead and trade on this. We can certainly go ahead and change variables if we want to calculate a different option price. And all we really have to do is change the strike price and also change the volatility. And then we can go ahead and execute these commands again so that we will get a new price for the new option. That simple. So there you have it. It's very easy to get started. We were able to get Dataproc up and running in a few minutes, and you saw how quick we're able to run a Monte Carlo simulation of 10,000 simulations to get a final result that is useful to us. Now that we're done with using the cluster, we should probably probably go ahead and shut it off because with cloud, it is charging us right by the hour. So one thing I want to note here is that I really like how the pricing of Google Cloud Platform works for Dataproc. It's really straightforward. Google is only charging 1 cent per vCPU per hour. So given we have 4 vCPUs for this cluster, we should be charged 4 cents. So very, very simple pricing. I really like it. So here we have it. So we have this cluster created. So let's go ahead and delete this cluster. Or better yet, maybe we should just delete the entire project. So I'm going to go over to this admin area and go to all projects. There is my option pricing project, and I'm going to select it and click delete project. And for safety reasons, Google doesn't want us to accidentally delete our project because that would be catastrophic. But since we know what we're doing, we'll go ahead and delete our project or shut it down. So there's a 7 days grace period that Google will be scheduling to delete after 7 days. So that's just in case if you do want to change your mind, if you want to go ahead and bring your project back, you can easily do so. Actually, one more thing that I want to try to do is to show you the UI for Spark. So if I go over to my compute engine, let's click on the menu here, go to compute engine. Let's find out what my external IP is. Here it is. So I'm going to click on this guy. And the port for this is 18080. Hit enter. Now this is going to fail. And the reason for that is I have not enabled or open up my firewall rule so that we can access the UI for this. So let's drill into my master node and let's go down to the network section. So I'm going to click on default. And I'm going to add a firewall rule here. So I will call this Spark. Okay, didn't like that. I'll call this, let's see if it likes this better. Oh, that's better. And I will put in just 00.0.0 because I want to access it from anywhere. But of course, in a production environment, you may not want to do that. And I'm going to open up the port, TCP 18080, and click create. And there it goes. And I'm going to hit that URL again, and we should shortly see the UI come up so we can see the job that was run. There you go. There's the history server. You can see the Spark logo here, and this is the job that ran. It looks like it was very quick. And one other thing I want to show before we go ahead and shut down the project is you can also look at the job information right from the Google Cloud Platform console. So let's go to Dataproc. Let's go to the jobs section right here. And it looks like there's nothing here. So one thing I will note here is that there are a few ways that you can submit jobs. And the way that we did it was through the Python interpreter, but you can submit jobs through jars as well. And you can do that right from here. So that's why we don't have anything to show here. Otherwise, you would be able to see all the different jobs that you're running right from the console. So there you have it. I'm going to go ahead and delete this cluster. Actually, delete the project. Again, I'm going to go down to the admin section and go to all projects and delete the project. Let's finish this one last task and then you can go ahead and try this out yourself. There we have it. So thank you everyone for watching. I will be posting the code I'm using to calculate the Monte Carlo or use the Monte Carlo simulation for option pricing. And I will also be showing the link of where I got the code originally from so you can take a look at what I've changed to make it work in Dataproc. And there you have it. Thanks a lot. Have a great day. Bye for now.